Alright, so to make sure I know where my graph is supposed to start heading back up in that V shape, I want to go ahead and find the vertex of my absolute value. And if you don't quite remember the vertex formula or haven't done it before with absolute values, it's going to be a brief intro on how to do that. So the form, it's kind of similar if you think of when we're looking at circles. If you have y equals a function, some value in front, your x minus a number plus k, then your vertex is going to be the opposite of h, k. Alright, so what we want to do is figure out how to make this look like this form, and then we can pull off a vertex. Just like how we had to manipulate the circle equations to find our center, we're going to have to manipulate our absolute value to find our vertex. So my absolute value is currently -2 minus x. But I want my x to be positive. So from my binomial, I'm going to factor out a negative, which leaves me with 2 plus x. And then when I can factor out that negative from the absolute value, so I end up with x plus 2. And then we might be going, but what's that k value in front? Or sorry, on the side. What number is being added to this? Well, we can be a little sneaky and we can say 0 is being added. And you might be asking, what's the a value? Well, remember, we got that invisible 1 in the front. So our vertex is going to be the opposite of this value, which would be -2, and then the number being added, which is 0. Alright, so, hey, that is a value we already found. Right there, that is my vertex. Okay, so this is good to know. That number right there is when my graph starts heading back up. So I can go ahead and graph these now that I know my vertex and some of the points. Choo-choo, and right there. There we go. So I'm going to go ahead and label all the points that I found. Please remember to do that on your graph. If they're kind of squished together, you can go ahead and use your little arrows so you can space them out a little bit. So that was 2, 4. That is 1, 3. That is 0, 2. The other one was -1 and -1. That was -2, 0. And here we had -7, 5. All right. Graphing that. Next page. Ooh, we have a piecewise function here. All right, this is going to be kind of interesting. So first things first, always make sure to go ahead and try and identify all of your equations. So this top one, what would you say that is? That's going to be linear. That's a line, because notice x to the 1 power. The next equation is x squared. Well, that right there is going to be a parabola, because it's quadratic. And then the next one we have 3 minus x. That is my absolute value equation. So what I'm going to do, my table of values. This one's kind of tricky because I'm going to be jumping around because we have different functions to be working with. Oops, sorry, you can't see that. Let's see, the splits happen at 2 and -2, so I'm going to be sure to include 2 and -2 in my table of values. But let's go ahead and choose some bigger negatives. I'll go with a -5. That still fits on my graph. And then let's pick maybe -3. Then we'll do -2. And how's about maybe we could do -1. Yeah, why not? Let's do -1. -1, 0, 1, 2, 3, and 5. Notice I tend to do the mirrors. I do the negatives and then the positives. All right, let's go ahead and figure out how to do these. So -5, which one does that fit into? It fits into this one because it's less than -2. So we're going to use x plus 6. So x plus 6 is going to equal. And notice with my piecewise, I included the function in the first step because these are all going to be different functions. So -5 plus 6, which equals 1. All right. And then -3, that falls into same thing, linear. And then the next one, -2. Ooh, that's not the linear. That's going to be part of the quadratic. So we're going to use x squared, which is going to equal -2 squared, which is 4. And -1. -1 will fall into, same, the quadratic category. It's between -2 and 2. So using x squared, it's going to be -1 squared, which is going to equal 1. 0! 0 also falls in the quadratic category. 1 falls into the quadratic again. 2 falls into, the absolute value. Oops. Ugh, that's ugly. All right. 3 minus 2. Oh, I did it again. All right. 1. And 3 will fall into that category again with the absolute value. And 5 will also fall into the absolute value category. Wow, that's a number of mistakes. Good thing I have the whiteout with me. And we can go ahead and create our points, x and f of x. So I have -5, 1, -3, 3, -2, 4, -1, 1, 0, 0, 1, 1, 2, 1, 3, 0, and 5 and 2. And remember, while we plot these points, we're going to keep in mind where these points are coming from. If they're coming from the linear equation, these 2. If they're coming from the quadratic, these 4. Or if they're coming from the absolute value, these 3. Let's go ahead and plot the linear ones first. -5, 1. 1, 2, 3, 4, 5, 1. And then -3, 3. -3, 3. Right there. All right, this makes sense because of our positive slope. Okay, and we know that this line is supposed to continue until we hit -2. Okay, so somewhere up here, it's supposed to stop. So I'm going to use my slope. My slope is +1. I'll go ahead and use my slope to count out my other point. 1, 1. And I know that this line is supposed to stop at -2. In fact, it's not actually supposed to go up to -2. So it'll stop right at -2. I'll use the open circle to indicate that. And I will use my ruler to graph my line. So there we go. We have graphed the portion of the line that is less than -2. Okay, let's go ahead and graph the parabola. So the parabola, let's see. Because we have a parabola, let's graph with our vertex. I'm going to find the vertex of my parabola. Actually, let me just write it. That's a wasted sticky note. Let me just go ahead and write it here. Okay, so vertex of the parabola. Vertex of x squared. So vertex, you take -b divided by 2a for your x value. And what's that going to be? My -b, well, you know what? X squared, the b value is 0, and the a value is 1. So this is going to be -0 over 2 times 1, which is going to be 0. Okay, that's my v sub x value. And my v sub y value is when I plug 0 into my equation and solve for x. So my v sub y is going to be 0 equals y squared. Remember we set the y value to 0. Oh, I'm sorry, I said that wrong. We're setting the x value to 0. So y is going to equal 0 squared, which is going to equal 0 as well. Okay, so that's my vertex, 0, 0. Ooh, which I already found right here. So I'm going to label that my vertex. Okay, so the times you want to check for your vertex are absolute values and quadratics. All right. So 0, 0 is my vertex, which means I know I'm going to be mirroring along here, because the axis of symmetry is actually going to be my y-axis. All right, good to know. So let's see the points negative 1, 1 and positive 1, 1. And I know that's going to mirror, let's see, negative 2, 4, negative 2, 4. Aha! Right there, negative 2, 4. That point gets filled out. And lastly, negative 3, 3. Negative 3, 3. Okay. So we could use the axis of symmetry and just gently plot that mirror point there and the other mirror point here. Because remember, parabolas have that mirroring quality to them when we graph them. So then we can go ahead and graph this. The question is, when do we stop graphing? This one is supposed to be in between negative 2 and 2. So we're going to stop at 2. That's where we're going to stop graphing it. Oh, I'm sorry. I plotted something wrong here. Too many points flying around. It was negative 2, 4, negative 1, 1, 0, 0, and positive. Oh, okay. Sorry, that went wrong. There we go. And notice again, I knew that I had plotted the points wrong because I know what a parabola is supposed to look like. So if you know what it looks like beforehand, you can catch your mistakes. Okay, so it's a good idea to make sure you know what the graphs are, because as you noticed, I have made mistakes on some of these. Okay, so we know it's supposed to stop there because it's in between negative 2 and 2. So in between negative 2 and 2. And then we continue on with our absolute value. All right, let's go ahead and find the vertex of our absolute value. Same thing we're going to do as we did last time. So let's get it into that form of x with a positive. So we're going to pull out the negative, so it's going to be negative 3 plus x. I'm going to rewrite that into absolute value of negative x minus 3. We can get rid of the negative by pulling it out. So we're left with x minus 3, absolute value. And then, for the sake of it, we do plus 0. So my vertex is going to be the opposite of 3, or sorry, the opposite of negative 3, which would be 3. And then whatever's being added, which is 0. Do I have that? Ah, I have that one right here. So that's my vertex for that equation. All right, so 3, 0 is my vertex. 1, 2, 3. So I know that this is where my absolute value is going to be starting back up. Let's go ahead and plot the other points from absolute value. So 2, 1, 2, 1. And then, let's see, 5, 2. 1, 2, 3, 4, 5, 2, 5, 2. And I'm going to make sure, can this equal 5? Yeah, it can. So I'm going to go ahead and draw my graph up there. The question here, though, is which of these graphs can 2 be included on? It's not being included to 2, so I actually filled in the bubble there. I should not have filled in the bubble there. It gets as close to 2 as possible. We don't actually touch 2 for the parabola. So we're going to use the open bubble. The one that does touch 2 is my absolute value. Okay, so it's going to go right up to this point, and we can include 2, so we're going to use the solid bubble. All right. And, oops, I forgot, this is supposed to go on continually. So there we go. All right, lots of steps for this one. But the main thing is, if you know what your main graph looks like, that really helps. Pick the points and the values that help you graph it, for example, the vertexes. And then check and make sure your endpoints, whether or not you're supposed to be including them, or including them or not including them. Okay. That's how we graph a piecewise function. If you want to check with your graph, I've uploaded a video to La Lima, so you could go ahead and have fun trying to check by plotting a piecewise function in your calculator. But let's look at determining if an equation is a function or not. So we have this one thing called the vertical line test, which is pretty much exactly how it sounds. So I'm going to draw a few examples of graphs. Now, they are not all functions, but we're going to use a vertical line test to determine which ones are functions. All right, so let's see. We've got this one, this one, this one, and a circle. So the vertical line test, we're going to be dropping a vertical line, and if it touches my graph more than once, it is not a function. So it touches more than once, it is not a function. Okay, so hopefully this is a review, but if not, here's a good time to learn it. So we're going to drop a vertical line. Boom. Does it hit my graph more than once? No. I could drop a vertical line a bunch of times. It will never hit my graph more than once. So, is this a function? Yes, and I'll put F for a function. How about this one? Well, if I drop a vertical line, boom, does it hit more than twice? Sorry, does it hit more than once? Yes, it hits twice. You might argue, but if I dropped it right here, it only hits that point once there. But if it breaks the rule in one place, it's just totally not in the party anymore. So this is not a function, NF. Now, please notice my F and NF, those are not mathematically correct. That's just for the use of the fact that I have very little space right here. All right, try check if these two are functions. Use the vertical line test and try to figure out which one is a function and which one is not a function. Okay, so dropping a vertical line, that does not pass. So that does not hit my graph in more than one place. So this is a function. Then I can go ahead, I'll drop a vertical line. That only hits once. But if I drop a vertical line here, it hits twice. Okay, so that is not a function. So not a function. Okay, so that was a mini refresher on what a vertical line test is. So we're going to go ahead to determine if the given information from these represents a function. Okay, so we're going to determine it algebraically. So what we do is the main definition of a function is for each x value, there will only be one y value. Okay, so let's go ahead and just pick some points to see if each x value I pick, I will only get one y value. So let's pick an x value, 0. Square root of 0 is going to be 0. Yeah, that makes sense. For each x, there's one y. Let's plug in another value. How about a positive? 1. Square root of 1 is also 1. Let's pick something else. How about 5? Do I only get one y value? Well, plugging in 5 for the square root of 5. Yep, just the square root of 5. So that was checking with the table. Another way you could check is you could just look at the graph. We know the generic version of this graph looks like that. Is that a function?